NEOJAN opens as a clinician-oriented decision support artifact for neonatal jaundice risk prediction. The first screen establishes the project identity, the clinical caution statement, and the main navigation structure. The demonstration shows that the platform is designed to accept multimodal neonatal data, generate risk estimates, and present outputs as advisory evidence rather than a substitute for clinical judgment or local neonatal guidance. This segment demonstrates the data input and prediction preparation workflow. A combined labeled CSV file is selected through the upload panel and added to the active session. NEOJAN stores the file, recognizes the tabular structure, reports the file dimensions, and confirms the merged dataset shape. The sidebar remains visible throughout, displaying the operating threshold, merge strategy, optional PCA view, animated threshold sweep, and prediction controls. The sequence therefore shows how raw, uploaded data become ready for model scoring. This segment focuses on the sidebar controls, manual threshold setting, and confusion matrix interpretation. NEOJAN first displays the default operating threshold loaded from the model bundle. A manual override can then be activated, allowing the demonstration to show how the working threshold changes before predictions are interpreted. After labeled data are available, the threshold optimizer can evaluate alternative operating points. The optimizer supports metric selection, beta weighting for the F-beta score, and configurable false positive and false negative costs. These controls allow threshold choice to reflect clinical priorities rather than a fixed technical value. In neonatal jaundice screening, sensitivity is commonly prioritized because missed high-risk cases may delay treatment. However, higher sensitivity can increase false positives and additional monitoring. NEOJAN therefore presents the trade-off transparently through metrics and visual summaries. After optimization, the page recalculates accuracy, sensitivity, specificity, precision, and F1 score. The normalized confusion matrix then shows true negatives, false negatives, and true positives as percentages. This visual summary helps the viewer understand how many cases are correctly reassured, incorrectly alerted, missed, or correctly flagged under the selected threshold. This segment demonstrates the prediction outcome page after the uploaded dataset has been processed. NEOJAN summarizes the analyzed row count, the number of alerts produced at the selected threshold, and the median predicted risk score. These indicators provide a cohort-level overview before individual interpretation is reviewed. The score histogram displays the distribution of predicted probabilities across the dataset. The threshold line separates lower-risk observations from samples that generate alerts. This visualization helps the user understand whether alerts are concentrated near the threshold or clearly separated from lower-risk cases. The patient selector then allows an individual sample to be examined. For the selected neonate, the gauge presents the risk score, the risk band, the threshold value, and the distance between the score and the alert boundary. This makes the individual result easier to interpret than a probability alone. The advice panel translates the numerical output into a cautious clinical narrative. It explains whether routine observation may be sufficient or whether additional review may be appropriate, while repeating that the prediction is only decision support. This wording is important because the model must be interpreted with bilirubin testing, clinical assessment, and local neonatal protocols. When labels are available, the outcome page also reports accuracy, sensitivity, specificity, precision, F1 score, and the confusion matrix. The surrounding charts extend interpretation by showing score behavior, patient ranking, and threshold utility. Together, the cohort indicators, patient-level gauge, narrative advice, visual analytics, and downloadable predictions demonstrate how NEOJAN moves from uploaded multi-omics data to transparent neonatal jaundice risk stratification. This segment presents the Analytics tab, which evaluates model behavior on labeled data. NEOJAN identifies the label column, counts labeled rows, reports class balance, and calculates prevalence. It then summarizes discrimination and calibration through ROC AUC, average precision, and Breyer score. The ROC, precision recall, calibration, and threshold sweep plots show how predicted performance changes across thresholds. This supports transparent review of sensitivity, specificity, precision, probability reliability, and operating point selection. This final segment reviews the About page and the visual theme settings. NEOJAN explains that its score estimates the likelihood of clinically significant neonatal jaundice requiring treatment. It also clarifies that the decision threshold converts a continuous probability into a binary alert. The explanatory section describes the trade-off between sensitivity and precision, the clinical meaning of false positives and false negatives, and the role of beta weighting in F-beta optimization. The page also lists suitable use cases, inappropriate use cases, score interpretation guidance, and supported performance metrics. The model bundle diagnostics confirm the detected operating threshold and its metadata source, which supports transparency and reproducibility. The theme controls then demonstrate alternative visual modes, showing how the interface can be adapted for presentation, review, and user accessibility preferences.